Everyone. So in this video, we are going to talk about this IGCSE 0580 Algebra Part 2. And this is a quick, brief revision of these concepts. In this video, we're going to talk about graphs in practical situations and sketching curves and drawing tangents to curves and differentiation. Let's see one by one. So first of all, if I talk about drawing graph in practical situations. So graphs in practical situations under this concept. So under this concept, the first thing that we should be aware of is the distance time graph. And the second thing is the speed or the velocity time graph. So first of all, whenever we have a distance time graph, whenever we have the first kind of graph that we should be aware of is distance time graph, or we simply call it as dt graph. So whenever we have these types of graph, the key point is to understand here is, so the distance time graph could be something like this. Let's say something like this and something like this. So here on the y-axis, we will be having the distance, and on the x-axis, it's going to be the time versus distance. So whenever we have a distance time graph, the first things to notice, so under distance time graph, so whenever we need to find the velocity of this graph, or basically the speed of the graph, speed is going to be the gradient of this graph. Gradient of this dt graph, which is the distance time graph. So usually in these types of questions, they will ask you, what is the speed or what is the velocity of the graph is. And next, so whenever we have a velocity time graph, or basically, so usually it's going to be a speed time graph. So the speed time graph goes something like, so whenever we have some random graph, something like this. So here on a vertical axis, there will be a speed, and on a horizontal axis, which is the x-axis, would be the time. And here, first of all, if they ask you what is the speed, so we just need to figure out. So suppose at this particular point, let's say at point A, so if I need to find the speed, so I can just view the graph and find it out. And whenever we need to find the acceleration at any point, so if I need to find the acceleration at this particular point, so that's basically the gradient of that line. So acceleration is going to be gradient of speed time graph. And then if I talk about the total distance traveled, so whenever the speed versus time graph is given, so and this is one of the very, very important question we should be knowing it how to answer this. So that's basically the total distance traveled. So whenever the speed time graph is given and the total distance traveled is going to be traveled between 2 points, is going to be same as area under the curve. Area under the graph. So that means we have to find the area of, let's say this is a parallel line. So in that case, it will be a kind of trapezium, or you have to split it like this. So then it forms up a two trapezium, and we need to find out the area of this entire shape, and that will give us the total distance traveled. So these are the key pointers that we should be aware of under the concepts graph in a practical situation. And the next concept that we have is so sketching curves. So sketching curves means all these Cambridge board would expect at this level. The sketching curve means so we have to construct a table, draw a table, and then so using that particular table of values, so we have to sketch the graph in the XY plane, and from there we have to figure out what is the x-intercept of the graph and everything. For an example, so it could be a graph of y equals to 2 into x cubed. So if I have a function, something like this, and if I need to graph it between -5 to 5 or -6 to 6, all I have to do is I have to construct a table here. So usually what type of question we will be having is, so we will be having the equation and already few values will be filled up and we need to fill up the remaining values. So for constructing a table, so we have to take few random values of x and we need to figure out the corresponding values of y. So suppose if x is 0, it's going to be 0 itself. If x is 1, it's going to be 2 times 1 cube, which is 2. If x is 2, it's going to be 2 times 8, which is 16. And if x is -1, of course, I could have written it before 0. If x is -1, it is going to be the graph is -2. If the x is 2, the graph is going to be -16. So, and roughly we have to plot all these pointers, all these points on the graph, and we have to draw a smooth curve. So when it is 0, it is going to be 0. When it's 2, roughly it's 1. So I'm going to take 1 unit to be something like this, and this is 2. Oh, this is 1. And when it is 2, it's 16. So 16 would be somewhere here. And similarly, when it is -1, it's -2. And when it's -2, it's going to be -16. So it's a cubic graph. So the graph would look something like this. We can also draw more points to get an accurate result or accurate graph. And this is the right answer. And for this table. And this is how we have to construct it. And the next thing that we have to look here is, so whenever we have any type of graph here, so suppose if I take some other random type of graph, so suppose if I have a graph, something like this. So here, the x-intercept or roots are the same. So whenever we say x-intercept of the equation or roots of the equation, both are exactly the same. So x-intercept or root means your the x-intercepts would be these 3 points, or the roots are those 2 points. And here we can also find the maximum or a minimum point. This point will act as the maximum point, and this point will act as the minimum point. Max or min. And this is what will happen. And the next thing is drawing a tangent and estimating the gradient of tangent. Tangent at a point. So tangents are a straight line which touches the graph exactly at one point. So suppose if you have a certain graph, something like this, let's say this is x and y axis, and we have some graph which goes something like this. And at a particular point, let's say at this particular point, I'm interested in drawing a tangent. So the tangent would look something like this. So this green line is the tangent, which touches this curve at exactly at one point. So whenever we can draw the tangents, and we can figure out what are the 2 points that the tangent is passing through from the given graph, and we will be able to find out what is the gradient of this tangent at this particular point. And this is what it meant by drawing a tangent at a point. And the last concept that we are going to have a brief recap is on differentiation. So differentiation is basically the rate of change, or basically change in the y coordinates with respect to change in the x coordinates. First of all, the notation we have is, so whenever you have y, and if we are differentiating it with respect to x, whenever we differentiate this one with respect to x, we denote it with dy by dx. And whenever we have f of x, and if we differentiate it with respect to x, it's going to be f dash of x. These are the notations. Now, in order to solve this differentiation, there is a couple of rules that you should be aware of. And the rules is, so d by dx, we call it as differentiation of. So d by dx of x power n. So the derivative of x power n is going to be n into x to the power of n minus 1. And the derivative of just a constant alone is going to be always 0. Here k, I'm taking it as a constant. And the derivative of constant into a variable, this is going to be equals to, we keep the constant as it is. Here, whenever you have a constant times variable, we have to just focus on differentiating the variable. So we should not at all think about differentiating a constant. We have to keep the constant as it is. We should never ever do it like differentiation of constant is 0 and differentiation of x power n is n into x power n minus 1. We should not think about doing it like that. So it is going to be k times x power n is going to be the derivative of x power n is n into x to the power of n minus 1. And this is what we have it. And this is something, these are the rules that we have to solve it. So for an example, if I need to solve, suppose if I have y equals to 2 into x to the power of 4. The derivative of this one is I have to apply the third rule. So that's going to be dy by dx will be equals to 2. I'm going to keep it as it is. The derivative of x power 4 is going to be 4 into x to the power of 3. So which is nothing but 8 times x cubed. And next, when we have y equals to 3 into x to the power of 5 minus just 2 plus x squared. If I have it something like this, the sum or the differences between any of these terms, we can differentiate it directly. When you differentiate it, we denote it with dy by dx. And this is equals to, we are going to keep this 3 as it is. The derivative of x power 5 is going to be 5 into x to the power of 4. Then minus the derivative of constant is going to be just 0 plus the derivative of x squared is going to be 2 into x power 1. And this is going to be 15 x power 4 plus 2x. And this is what is the derivative of this 3x power 5 minus 2 plus x squared. Now, one of the application of differentiation that we have is graphically. So you can also say it as graphical or analytical graphical application of differentiation. So whenever you have any graph and whose the function or the equation is given, we can always find out what is the gradient of a tangent of that particular graph using the concept of differentiation. So if I need to find out the gradient, whenever I just say gradient at a point x equals to a, or if I say gradient of tangent, at x equals to a. So both are exactly the same. And this is going to be same as the derivative at that particular point. Derivative at x equals to a. So which means, for an example, if I have y equals to x cubed minus 2x, something like this. And if I need to find out what is the gradient at x equals to 1, I'm interested in finding the gradient at x equals to 1. So in order to do that, so first of all, we have to differentiate this. So the derivative is going to be dy by dx is equals to the derivative of x cubed is 3 times x squared. So using that x power n rule, and minus whenever we have a constant into a variable, we keep the constant as it is. So we keep this 2 as it is, and the derivative of x is going to be just 1 into x to the power of 0. So which is just 1. So it's going to be the derivative is 3x squared minus 2. And if I need to find the gradient of tangent at x equals to 1, at x equals to 1, so dy by dx value is going to be 3 times 1 squared minus 2, which is going to be 3 minus 2, which is just 1. So 1 is the gradient. And this is how we find the gradient. And the next thing under differentiation we should be aware of is stationary points or turning points. Or turning points. So stationary points or turning points is basically the points where the gradient of a tangent is just 0. So something like this. So the gradient of tangent is 0. So those points we call it as the stationary or a turning point. So we have just seen this. The gradient of tangent is basically the dy by dx. So that means when dy by dx is 0, we can find the stationary points. The stationary points are the x coordinates when dy by dx is 0. For an example, if I have y equals to x cubed minus 3x, if I need to find the stationary points here, I have to find the derivative. So the derivative is going to be the derivative of x cubed is 3 into x squared minus the derivative of 3 times x is just 3. And I have to equate it to 0 and to solve for x. So when I equate it to 0, it's going to be 3x squared is equals to 3. Then x squared is 3 over 3, which is just 1. So then x is going to be, when square goes to the other side, it becomes plus or minus square root of 1. So x equals to either positive 1 or x equals to negative 1 is the x coordinates of the stationary point. And if I need to find the corresponding y coordinates, I have to substitute it in this function to get the result. Next, if I talk about the last concept in differentiation we have is, we have something known as nature of stationary points. nature of stationary points means, so we need to figure out what are the stationary points here and whether the stationary points are maximum or a minimum point. Whether the given stationary point is a maximum point or a minimum point. To be more specific, we call it as local maximum or local minimum. The maximum point means whenever you have a curve, something like this. And this particular point, we call it as the maximum point. And whenever you have a graph, something like this bottom point, we call it as the minimum point. So in order to solve this, now all we need to do here is, in order to check whether it's a maximum or a minimum point, all we need to do is we have to find the derivative and find the stationary points first. So that's the step number one, because only your stationary points can be your local maximum or local minimum. So find the stationary points. So when I try to find the stationary points, so that's nothing but dy by dx is equals to, so for the same question, if I take it as y equals to x cubed minus 3x, dy by dx, we know it as 3x squared minus 3. And when I equate it to 0, I'll be getting x equals to positive 1 or x equals to negative 1. These are the stationary points. And this is, we call it as the second derivative test. So that's basically step number 2 is find the second derivative. So find the second derivative means we have to differentiate this function for one more time. So d squared y over dx squared. So d squared y over dx squared is going to be equals to, the derivative of 3x squared is going to be 6 times x, and minus the derivative of 3 is just 0. Now, once when we find the derivative here, the second derivative, and we can substitute the stationary points. And after substituting the stationary point, if the second derivative is positive, if it is greater than 0, it's a minimum point. So at that particular x coordinate, there will exist a minimum point. And if the second derivative is negative, so that means if it is less than 0, then it's a maximum point. Which means, yeah, so I can clearly see it. When I put positive 1, I'll be getting positive 6, which is greater than 0. So that means at x equals to 1, there would exist a minimum point. And when I put negative 1, the second derivative would be negative 6. So which is going to be just negative, which is less than 0. At x equals to negative 1, there will be a minimum point. There will be a maximum point. These are the things that we should be aware of under differentiation. So based on these concepts, so let's try a few questions. So here is the first one, and this is from paper 2. And the diagram shows a speed time graph. So here we have the speed time graph for 24 seconds here. A car journey. Calculate the deceleration. So that refers to the acceleration of the car in the final 8 seconds. So this is what is the final 8 seconds. I have just mentioned it to you. So the acceleration in the speed time graph is going to be always the gradient. So which means we have to find the gradient. So this point is going to be 16,12. And this point is going to be 24,0. So in that case, so deceleration is going to, the acceleration is going to be negative. So whenever the acceleration is negative, we call that to be a deceleration. It's y2 minus y1 over x2 minus x1. That's how we find the gradient. It's 12 minus 0 over 16 minus 24, which is nothing but 12 over negative 8. So which is nothing but negative 3 by 2. The reason why we say decelerations, of course, the acceleration is negative 3 by 2. So we call that to be a deceleration. So that's going to be just positive 3 by 2 meter per second square. This is what is the deceleration. And this is the right answer for part A. Next, for part B, we need to find the total distance traveled here. So here, the total distance covered is the area under this curve. So we have a rectangle and we have this triangle. So in that case, the total distance traveled. So the total distance traveled will be equals to sum of these two areas. So the area of a rectangle is the height is 12 and the width is 16. It's going to be 16 times 12. Then plus area of this triangle is half into base into height, which is half into. The base is going to be 8 and the height is going to be 12. And this is something that we have to calculate it and get the answer. So this 2 ones are 2 fours are, it will get cancelled out. And next, if I talk about 16 times 12, that one plus 16 times 12 is 192. That plus 4 times 12 is 48. So that's going to give us the result as 240. So since the speed is in meter per second, it's going to be meters. 240 meters is the total distance traveled. And next, I'll take another question on the graph, and here it is. So here they have mentioned as the cubic graph, and here we don't have to construct a graph. The graph is already mentioned, and it's the cubic graph here. So now for part A, the diagram shows the graph of y equals to f of x, where x is between negative 1.5 to 5. We need to figure out what is f of x, f of 2. F of 2 means it is the graph when the function is 2. When the x coordinate is 2. When the x coordinate is 2, when the x coordinate is 2, I can clearly see it. The point is somewhere here. So this is clearly between negative 2.8 to negative 3, so which is going to be negative 2.9. And this is the answer. Next, for part 2, solve the equation f of x equals to 0. When I say f of x equals to 0, that means when the y coordinate is 0, what are the x coordinates we have? So the x coordinates are this point, and this point. So this is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's clearly negative 1. And this is 1, 2, 3, 4, 5, 6. So which is 1.6. And this is 1, 2, 3, 4. So we have this negative 1, 1.6. Then we have this 4.4. And this is the right answer for part 2. And next, f of x equals to k has 3 solutions, where x is between negative 1.5 to 5, where k is an integer. Find the smallest possible value of k. So whenever we say f of x equals to k, that means it's going to be a horizontal line passing through some k. So and we need to figure out what is the smallest integer value. It can't be negative 9, because at negative 9, if you draw a horizontal line, the graph will not intersect at 3 different points. So, but it can be negative 8. When I draw a horizontal line at negative 8, so when I say f of x equals to negative 8, this is going to be a horizontal line passing through negative 8. And this line would intersect the graph at 3 different points. So that's the reason. So I can say it. K is going to be -8. Next on the grid, draw the line y equals to mx so that f of x mx has exactly one solution. So y equals to mx means your y-intercept is 0. So it needs to have exactly one solution. So it can't not have more than one solution here. So we just need to sketch it here. So that means the line, whatever I'll be drawing it here, that should intersect the graph exactly at one point. And I cannot draw the line something like this. If I draw a line which has the positive gradient, definitely the line is going to intersect the graph at more than one point. So that's why we have to draw the line with a negative gradient. So something like this. And this line will intersect the graph exactly at one point. And again, I should not draw a line something like this because this line would probably intersect the graph at 3 different points. So this is the right answer for this part. For part B, y equals to 3x squared minus 12x plus 7. So we need to find the value of dy by dx when x is 5. So dy by dx in this case is going to be, when I differentiate this, the derivative of 3x squared is going to be 3 times x squared. So it's going to be 6 times x. Then minus the derivative of 12 times x is going to be just 12. Because whenever the derivative of a constant into variable, it is just going to be a variable. And then the derivative of 7, which is going to be just 0. And at x equals to 5, if I need to find this, so dy by dx is going to be equals to 6 times 5 minus 12. So which is 30 minus 12, which is 18. 18 is the right answer for B part 1. Next, for B part 2, find the coordinates of the points of the graph where the gradient is 0. So the gradient is basically dy by dx. When we differentiate this one, so we have just gotten it in part B. So when we differentiate it, we got 6 minus 12. And we need to figure out at what coordinates that x is going to be 0. Sorry, the gradient is 0. So that means I'm going to equate this to 0 and solve for x. So it's going to be 6x equals to 12. Then x is going to be 12 over 6, which is 2. So the x coordinate is 12, and we should find the corresponding y coordinate as well. When the x coordinate is 2, we need to figure out what is the y coordinate as well. And when x is 2, y is going to be 3 times 2 squared minus 12 times 2 plus 7. So which is nothing but 3 times 2 squared is 3 times 4, which is 12, minus 12 times 2 is 24, plus 5. And this is going to give us the result as, so minus 12 plus 5, which is nothing but minus 7. And this is the answer. Next, for part C, we are talking about when 2 into x power p plus q into x squared will give you dy by dx is equals to 14x power 6 plus 6x. So find the value of p and q. So when I differentiate this one, so dy by dx is going to be equals to the derivative of 2 into x power p. So we'll keep this to us. Derivative of x power p is going to be p into x to the power of p minus 1. Then plus, this is going to be q, I'll keep it as it is. The derivative of x squared is going to be 2 times x. Now they are saying this is what is equals to 14x power 6 plus 6x. So in place of 14, we have 2 times p. So 2p is equals to 14. And in place of 6, we have 2 times q. So 2 times q is equals to 6. So this is going to give us the value of p to be 14 over 2, which is 7, and q to be 6 over 2, which is 3. So that's the reason the value of p is 7 and q is 3. Here we have another question here. So the equation is given. Equation of the curve is given. When x is 2, the gradient is given as 6. This means, so using the concept of differentiation, so when x2 dy by dx is going to be equals to 6. And this is something that we can substitute it and solve it. And in order to substitute it, we have to find the derivative first. So y is given here. So dy by dx will be equals to. So the derivative of x cubed is going to be 3 times x squared minus k. The derivative of x squared is going to be 2 times x. And the derivative of a constant is going to be just 0 here. And here, so the gradient is 6 when x is 2. So that means it's going to be 6 is equals to 3 times 2 squared minus k times 2 times 2. So which is nothing but 6 is equal to 3 times 2 squared, which is nothing but 3 times 4, which is 12 minus 4 times k. I'll take 4k to the left-hand side, 6 to the right-hand side. So that's going to give us 4 times k is equals to 12 minus 6, which is just 6. That will give us the value of k to be 6 over 4, which is going to be 1.5. This is what we're supposed to show it. And next, find the coordinates of 2 stationary points. The stationary points are when the derivative is 0. So that's dy by dx is equals to. The derivative of x cubed is going to be 3 times x squared minus, this is going to be 2 times 1.5, which is 3 times x. This is what is the derivative. When I put it to 0, I can factor out x common. So it's going to be 3x times x minus 1 equals to 0. So it's going to be 3x is equals to 0, or x minus 1 is equals to 0. So which means either x is 0 or x is, when minus 1 goes to the other side, it becomes positive 1. So x equals to 0 or x equals to 1. Whenever they say coordinates, we have to find the x as well as the y coordinates as well. And when x is 0, if I substitute it here in the original equation, we can get the value of y. So when x is 0, y is going to be 0 cubed minus 1.5 times 0 squared plus 1. So which is going to result in just 1. And when x is 1, so y is going to be 1 cubed minus 1.5 times 1 squared plus 1. If I solve this, so 1 minus 1.5 plus 1, so that's going to give us 0.5. So the coordinates are going to be 0, 1 and 1, 0.5. That's the answer. And next in part C, talking about sketching this graph. So for sketching this graph, we should consider all these pointers. So first of all, we have the stationary points to be 0, 1 and 1, 0.5. So I'll take these points to be -1, -2, +1, +2. And here the y-intercept is +1 itself. +1, +2, -1, -2. So each unit I'm just taking as 1. So the stationary points are 0, 1. So the point 0, 1 is here. And oh, this is positive 1, this is negative 1. The stationary point is 0, 1. So this point is what is 0, 1, not this one. And the other stationary point is 1, 0.5. 1, 0.5. So somewhere here. So I can clearly see it. The graph would look something like this. And here, if you want, we can figure out what are the values at 2 and at -1 and all what are the values. So at x equals to 2, the gradient is 6. So that means it will be very, very steep. So in this case, when x is -1, it's going to be y equals to -1 minus 1.5 times -1 squared plus 1. And if we simplify this, so this is going to be -1 cube is -1, and this is going to be -1.5 plus 1. So this is going to give us -1.5, something like this. And when it is 2, it's 2 cube -1.5 times 2 squared plus 1. So 2 cube is 8 and 2 squared is 4. 4 times 1.5 is -6 plus 1, which is nothing but 3. At 2, it is going to be 3 here. So that's why. So we can just plot this graph by connecting these points. And this should be the answer for this graph. And these are the types of questions that we will be having it based on this differentiation.